I'm Won Lee. This is a new chapter, Chapter 8, Regression Analysis. Today, I'm going to explain about the simple linear regression model. Okay, it is not difficult, easy, and regression analysis is my major. Okay, let's see. What is that model? Simple linear regression model. Regression analysis is a fundamental statistical analysis techniques as important as analysis of variance. It is important. Important means many people use regression analysis to analyze their data. The purpose of a regression analysis is to specifically investigate the relationship between a variable y takes on different values due to the influence of another variable x. Influence, okay, of another variable. We like to relation between y and x. The random variable can be expressed as y equal to mean of y plus epsilon. We studied x equal to its mean plus epsilon. Here, epsilon error is a random variable so that x is random variable. Random variable means taking various values, right? And we want to express the mean of y in terms of another variable x. We like to express this one, okay, in terms of another variable x. For example, the height of sun y can be considered as the sum of its average height, sun's average height, okay, and error, sum of these two terms, which allows it to take on different values. That's why epsilon is random variable. That's why y is also random variable. Oh, by the way, I use random variable y instead of x from what? ANOVA, chapter 7, right? Because linear regression model here, we have to use y here. So that from ANOVA, we used to use random variable y instead of x. Do not be confused. For example, okay, here, which allows it to take different values. Here, we want to express the average height of sun, this one, in terms of another variable, namely father's height, x. Okay, we want to express this one with another variable, x. Of course, mother's height may also be included in addition to father's height. We can add another one, x and x2. Then, in that case, we want to use x1 and x2. x1 is father's key height, x2 is mother's height. That's what I mean here. So we are going to simple, okay, multiple linear regression model later. In this case, we said multiple linear regression. Okay, in other words, let's express the sun's height y, expected value, expectation of y plus epsilon. This one goes to here. Beta 0 plus beta 1 x. Okay, we want to express y like this. That is a base of linear regression model. Assumption follows. Epsilon has normal distribution with mean 0, variance sigma square, same as we did in ANOVA. We call y the response variable and x explanatory variable. That is a better name, okay? This is independent, okay? This is dependent. That those terminology are from mathematics. Y equal to 3x plus 2, something like that. From mathematics, We said x is independent, y is dependent variable. Anyway, okay, here in fact, x is also a random variable that can take on some values, but these values are treated as given. Treated as given means constant, not variable. If x is also random variable, then it becomes very complex. Somebody research this kind of a part, but x is a random variable, but we do not say x is a random variable. The values of x are given. Okay, the primary objective is to estimate the parameter beta 0 and beta 1 from a paired sample like this: yx, y1, y2, yn, and y1, x1, y2, x2, yn, xn, to get an estimated linear line like this. We get estimated from data beta 0 hat, beta 1 hat, estimate, then we can get a linear line. So we have a hat here, so we denote it y hat, same hat. Now, simple linear regression model is as follows: yi equal to beta 0 plus beta 1 xi plus epsilon I from 1 to n is a number of a sample, okay? Number of, this sample size. Assumption, same assumption. IID, you remember, independently, identically distributed, normal, 0, sigma square. Okay? From the assumption about the errors, the response variable yi, this one, will be yi will follows normal distribution with the mean what? This one is mean. Beta 0 plus beta 1 xi. What is variance? Variance is just the sigma square, right? Once again, let me emphasize the values xi are considered as given values, not random variable. If random variable, it is much more complex. Okay, is that it? How about this? Simple, right? All right, this is it today. Thank you. Bye.